So this one is electrolysis and chemical cell exercise. We did the last session MCQs. First session, 8 MCQs we did. Remaining you will solve with the homework. And once I share with you as a weekly homework. Now we'll do the structure questions. So we did first few questions from this exercise, but as a continuation, I will solve them again. So we have aqueous copper 2 sulfate is there. The ions which are present, copper ion, sulfate ion, hydrogen ion, and hydroxide ion. Write an ionic equation for the negative electrode or cathode. So which ion will move? The less reactive ion will move. So which is less reactive? Copper is less reactive. And when copper will move, what is the equation? The copper ions are there. They will take 2 electrons and it will form a copper atom. For negative ion, we check the amount because sulfate, carbonate, and nitrate, even though they are more or less, they will not move. So there will be a hydroxide ion. And whenever hydroxide ions are there, it will give oxygen. So a colorless gas was given off at positive electrode and the solution uh, changes from blue to colorless. So explain these observations. What is the colorless gas? The colorless gas is due to oxygen. Like when 4 hydroxide ions are there, they will form oxygen and give off 2 water molecule plus 4E. So what is the colorless gas? The colorless gas is oxygen. And why the solution turned from blue to colorless? Because the copper ions are blue in color. So the concentration or amount of the copper ion decreases in the solution as the copper ion is discharged at cathode. So the copper ions concentration or the amount decrease. That's why the solution will get colorless. If the concentration of the copper ion remains same, then the solution does not show any color change. Like example, if you do electrolysis of copper to sulfate using copper electrode, in that case, the electrode will change only, but the solution, there is no change. In question 2, aqueous copper 2 sulfate is electrolyzed using a copper electrode. So we have a copper electrode in this case. And when we are doing the electrolysis, anode cathode made up of copper, and there's a copper 2 sulfate solution, copper ion, sulfate ion, hydrogen ion, and hydroxide ion. Copper ions are less reactive, so they will move towards cathode. And as the amount of the copper ion in the solution is changing, to balance that, the copper atom will go inside the solution as a copper ion. So write equation for the positive electrode at the, because this is an electrolytic cell. So what happened at the positive electrode or anode? The copper atom turned into copper ion by loss of 2 electrons. Why the color of a solution does not change? What is the reason for that? Because there is no change in the concentration of copper ion in the electrolyte. And what is the reason for that? Because the number of the copper ion enter the electrolyte is equal to the copper ions exit the solution or move out from the solution. Like if one copper ion is entering the electrolyte at the same time, like if this is entering, going in, this one is going out. So the amount of copper ion discharged at cathode is same as the amount of copper atom turned into copper ion in the electrolyte. What is the large scale use of this electrolysis? This electrolysis is mainly used for purification of the copper. If you want to purify copper, we can use this method. Question 3. Now this is a chemical cell as we did today the topic. So what happened in this chemical cell? You can see question 3. You can see 2 electrodes are there. One is zinc, another one is iron. Which is more reactive? Which one is more reactive?
Zinc.
Zinc is more reactive. So zinc is more reactive. What will the equation for a zinc? Zinc electrode will turn into zinc ion. So zinc atom turn into zinc ion by loss of 2 electrons. Then because it's a loss of electrons, so when anything lose electron, we call this change as oxidation. Or what is a reductant here? Oxidation for substance which oxidation happen is a reductant. So what is a reductant here? Zinc atom is a reductant. Now, as a result, the electron will move from zinc to iron. So majority of the electrons will be here now. As they move, initially they're at the zinc plate, then they move to iron. And this is a sulfuric acid. So sulfuric acid, what it contain? It contain hydrogen ion, it contains sulfate ion, it contains hydroxide ion and hydrogen ion. Because acids and alkalis are always aqueous. So which is the less reactive positive ion? The less reactive positive ion is hydrogen. So this hydrogen will move towards electrons, the copper plate, iron plate or iron electrode. And what is the equation at iron electrode? When hydrogen ion is there, it will take 1 electron from hydrogen atom. When 2 hydrogen ions are there, they will take 2 electrons and it will form a hydrogen gas. That's why bubbles of a hydrogen are seen. Now, what is this change? Because it's a gain of electrons. So whenever something gain electron, remember from reduction is a gain. So this will be a reduction. And for substance which reduction happen, that is a oxidant. So what is the oxidant here? Here hydrogen ion is the oxidant. Because reduction happened for hydrogen ion, so it is the oxidant. So which substance in this cell is a reductant and which ion is the oxidant? So which substance is a reductant here? That is zinc. And which ion is the oxidant? Hydrogen ion is the oxidant. Is it clear? How could the voltage of this cell be increased? Like we are using zinc and iron. I want to increase the voltage. What I should do? What we should do to increase the voltage of a cell? Increase the difference, or I can also say use a metal which is more reactive than zinc or use a metal which is less reactive than iron or use two metals. So even this is acceptable because when you say use metal which is more reactive than zinc or use a metal which is less reactive than iron. Or you can mention use two metals which are having a greater difference in the reactivity. Titanium is a very resist to corrosion, one of this electrolysis hydrogen hydroxide ion in a seawater. So define the term oxidation. Oxidation you will remember from oil. Oxidation is a loss of electron. Steel is a cathode. Name the gases form. Name the gas form. So cathode we have sodium ion and hydrogen ion. So hydrogen ions will move towards cathode. So there will be a hydrogen because a less reactive will move. Two gases, because it contain hydroxide and chloride. So hydroxide ions will move towards anode and chlorine also move towards anode. And when hydroxide will move, we don't say hydroxide, we say oxygen gas will be there. And when chloride ion will move, so there will be a chlorine gas. This is about electrolysis of substances, aqueous and you have to work out Yeah, we did this, but quickly I will go through as I'm recording in sequence. So if you, whenever change in electrolyte, if it is used up, it means the substance should be molten. Because only in molten substances electrolyte is used up. So potassium and iodine, so this is potassium iodide. If we have dilute aqueous sodium chloride, so it contains sodium ion, it contains chloride ion, it contains hydrogen ion and hydroxide ion. Which positive ion will move towards? So hydrogen is less reactive. Hydrogen will move towards the negative electrode, so there will be a hydrogen. Because it's a dilute, so dilute means it contains more OH and less Cl. So hydroxide ion will move. So when hydroxide ions will move, so there will be oxygen gas. And what we are left with, we are left with NaCl. So this solution will become like more sodium chloride will be there. So we'll say it will become concentrated sodium chloride. When H and OH are removed, the solution will become concentrated. If we have aqueous copper 2 sulfate, so it contains copper ion, it contains sulfate ion, it contains hydrogen ion and hydroxide ion. Copper ions are less reactive, so there will be a copper formed. Sulfate, nitrate, and carbonate never move. So it will be hydroxide, hydroxide. So it means there will be oxygen again. And what we are left with? We are left with H ion, hydrogen ion, and we are left with sulfate ion. So hydrogen and sulfate ion, what they will make? It will make H2SO4, which is known as sulfuric acid. So the electrolyte will turn into sulfuric acid. Here, in this case, potassium hydroxide is there. So means we have potassium ion, we have hydroxide ion, hydrogen ion, and we have bromide ion. So if all these ions are present, what should be the substance? The substance should be aqueous potassium bromide. But whether it is concentrated or dilute, how you know? Because if it was dilute, then hydroxide will be more, oxygen should be there. It means it should be a concentrated, the solution is concentrated, aqueous concentrated potassium bromide. That's why the bromide ions are moving towards the positive electrode. This we did in the last session. That's why I quickly go through this question. Now, question 6. Another way of finding the order of the reactivity of the metal is measuring the voltage and the polarity. Polarity means like positive and negative charge when we write. The polarity of a cell by which the metal is positive electrode and which metal is negative. Example, zinc and lead are there. Which is more reactive? Zinc or lead? By looking at the polarity, you can also tell. Because always the negative one is a more reactive. So zinc is more reactive and lead is less reactive. Mark on the above diagram the direction of electron flow. So you can use screen annotation. Annotate on the screen how the electrons will move. What will the movement of electrons? Use the screen annotation. No, the movement of electron is always from more reactive to less reactive. So it's always from more reactive to less reactive. So it should be from zinc to lead. Explain in terms of electron transfer why more reactive metal is always a negative electron. So the same question as you asked when I was explaining why more reactive is a negative electrode. So first thing, what is the answer for this? The more reactive loses electron readily or easily. You can say readily, you can also say easily. And when it loses electron readily or easily, what will happen? most of the electrons are present on the more reactive metal. So in this case, what will happen? Because zinc is more reactive, zinc is more reactive. So when this zinc will lose electron, it turn into zinc ion. So majority of the electrons initially they're here. Then they repel and then repulsion cause a motion. But initially most of the electrons are here. That's why it is a negative electrode. Is it clear? This one? Why the more electrons are at the most reactive? Because the most reactive is losing electron easily. As they're losing electron easily, that's why they have majority of electrons on them. Because like zinc is more reactive, so zinc turn into zinc ion, and the electrons will be here majority because electrons cannot move in the electrolyte. So there's a buildup of electron on this electrode, and that buildup of electron makes this negative because electrons are negatively charged. The next one, the following table gives the polarity of the electrodes. As we know, the one which is a negative, it should be a more reactive. So we have to set up the reactivity, use information about what information about the reactivity of these four metals can you deduce from the table? So for zinc and lead, which is more reactive? Zinc is negative, lead is positive. Which is more reactive? What we can say, which is more reactive? Zinc is negative and lead is positive. So we can say zinc is more reactive than lead. Then from cell A, in using a cell A, we predicted that zinc is more reactive than lead because zinc is negative and lead is positive. What about cell B? Which is more reactive? Cell B. Manganese, because manganese is negative and lead is positive. So manganese is more reactive than lead. Then cell C, which is more reactive. So cell C shows that the lead is more reactive than copper because lead is negative and copper is positive. So, or we can conclude that copper is the least reactive. Like here, if I set up the reactivity, zinc is more reactive than lead. Manganese also, we don't know whether which is more reactive between zinc and manganese. Manganese also more reactive than lead, but lead is more reactive than copper. So it will be this type of a reactivity. What additional information we need to establish the order of the reactivity of the four metals? What I need? Additional information to know the exact position of their reactivities. What? No, no, not series. Like what additional thing I need to set up the reactivity? Like I can exactly know what is the position of zinc, manganese, lead, and copper. Yeah, what we need. So what we need here, we need a voltage. We must know their voltage, because if we know their voltage, we can exactly form up the reactivity series. Like what is the position of manganese, zinc, lead, copper? How much higher the voltage, greater the difference in the reactivity. So the additional information which we need to set up the reactivity or establish the reactivity, we need the voltage. Is it clear, this question? Anyone having a doubt till this point? Okay. Moving on to the next question. Again, you can see the following diagram shows a simple cell. Tin is there and zinc is there. Predict how the voltage of a cell would change if a tin is replaced by silver. Like tin is more reactive and silver is like silver is the least reactive. So if I change tin with silver, what happened to a voltage? Will it increase or decrease? Tin is not shown in that reactivity series which we discussed, but the idea is given to you that you're using a silver. So silver is like the position where least reactive metal, silver, gold, platinum, these are least reactive metal. So when we set up the reactivity series, the common reactivity series, which include potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, and platinum. So silver is on the side of the least reactive metal. So if we replace this tin with more like a least reactive metal, if we replace with a silver, what will happen to the voltage? The voltage of a cell will increase. So increasing the difference in the reactivity increases the voltage of a cell. The next question is, which electrode will go in the solution as a positive ion? Give a reason of your choice. You have zinc, you have tin. Which one you think will go inside the solution? Is it zinc or tin? More reactive is zinc. So which one will go inside the solution? So zinc is more reactive, it will go inside the electrode, which will go inside the solution. You will mention zinc. And what is the reason for that? Because it is more reactive. So more reactive metal always go inside the solution as a mean. State how you can predict the direction of electron flow of in the cell of this type. How you can find the direction of electron flow for the cell of this type. Yeah. So what will the electron flow for these type of a cell? The electron flow is always from more reactive to less reactive. So we can predict, yeah, it will be from more reactive to less reactive. It will move from more reactive metal to the, because more reactive can easily lose electrons, so it will always be in this case. This is electrolysis. We are focusing on cell questions, so I will quickly go. Zinc forms and at the negative electrode, write the equation. So if zinc ions are there, they will take 2 electron and it will form zinc atom. Write equation for the positive electrode at anode. Sulfate never moves, so when hydroxide ion will move, 4 hydroxide ions are there, they will give oxygen, 2 water molecules and 4 electrons. The electrolyte changes from aqueous zinc sulfate to, because zinc is removed and hydroxide is removed. So what we are left with? We are left with hydrogen and sulfate. So it will turn into sulfuric acid, which is hydrogen sulfate. So it changes from zinc sulfate to hydrogen sulfate. Electrolysis question I'm quickly going because I want to solve the cell questions, as we did earlier, these questions. Complete an ionic equation for hydrogen ions. When two hydrogen ions take two electron, it will form a hydrogen gas. When two chloride ions loses two electron, it will form a chlorine gas. Why the solution changes from sodium chloride to sodium hydroxide? Because hydrogen ions are removed, chloride ions are removed. So the ions which are left in this electrolysis is a sodium ion and hydroxide ion. That's why the solution turned into sodium hydroxide. This is a cell which is used. The zinc electrode have been used in the cell for many years. One of the first was a Daniel cell in 1831. Uh, as I mentioned, usually in a chemical cell you have a salt, but usually in a chemical cell you have acid as electrolyte, but some cases you also have salt solution. How this cell will work? How this cell will work? First, you have zinc sulfate, so there are zinc ions, hydrogen ions, and this is copper sulfate. Copper ions and hydrogen ions are there, and sulfate ions are also there. Hydroxide and sulfate ions in both. Zinc is more reactive. So as zinc is more reactive, the more reactive will lose electrons, so zinc will lose electron and it will turn into zinc ion. So zinc electrode, what happens? Zinc atom turn into zinc ion by loss of two electrons. And what happened to the zinc electrode? Its size will decrease. The electron will move from zinc to copper. In this case, in the solution, we have copper ion and hydrogen ion. Because the copper ions are less reactive, so they will gain electron. Before it, if it was an acid, hydrogen ions are there, they can gain electron, but now the copper sulfate contain copper ions. Copper ions are less reactive, so they will gain electron. So as a result, when copper ions are there, they will gain two electron and it will form copper atom. So what happened when metal is formed? The size will increase. So one side the size will decrease, other side the size will increase. Now in the question, give an explanation in terms of atoms and ions. First one, observation at a zinc electrode. What we observe at zinc electrode, the electrode become smaller. So why the zinc electrode becomes smaller? We have to explain in terms of atoms and ions. So we'll mention the zinc atoms. The zinc atoms changes to zinc ion. That's why the electrode becomes smaller. And why the copper electrode become bigger? Because what happened, the copper atoms, the copper ions from the electrolyte turn into copper atoms. So when atom turn into an ion, the size will decrease. When ions turn into an atom, the size will increase. When a current flow, the charge particle move around the circuit. What type of a charge particle move through the electrolyte or through the solution? So through the solution, only ions can move, and through the wire or the voltmeter, electrons can move. So what type of charge particle move through the electrolyte? It's only ions, positive and negative ions. And what moves through the wire and the voltmeter? Electrons. So electrons can only move through the wire and ions can move through the solution or electrolyte. The copper oxide is reduced to copper, which is then refined by electrolysis. Label the diagram of the apparatus which could be used to refine a copper. Like if you want to purify a copper, So if you want to purify a copper, this one is anode. This one is a cathode. Like the negative one is a cathode. And this one is a anode. And this is an electrolyte. 2 minutes. So what will happen for this electrolysis? If you want to purify this copper, anode is made up of impure copper. No, you have general term is electrolyte. It's not like this is an electrolytic cell. So when you are using a purification, so you for a purification of a copper, anode is made up of impure copper. If these dots are representing the impurities, like these dots are representing the impurities, when the copper atom will go inside the solution as a copper ion, the impurities are left behind. And what cathode is made up of? Cathode is made up of pure copper. So the copper ions will move towards the cathode and it will attract and the cathode size will increase. And what is it? This electrolyte is made up of? It is made up of copper sulfate, aqueous copper sulfate. So the copper ions will go inside the solution and the copper atoms turn into copper ion from the anode, and then the copper ion from the electrolyte will move towards the cathode. Give one use of a copper other than making an alloy. If you want to, what is the use of the copper other than alloy? So we can use it. Yeah, this method is electroplating. This is actually like same idea is there, purification of a copper or electroplating. So we can use copper as electric wires as well, because copper is a conductor, so we can use as a electrical wires. So these are the questions I did till the structure question till 11. There are about 20 questions, so almost half of the exercise I did with you. And this was about the electrolysis.